So you run a program, you get an error message, it doesn't work. What do? Well, what you don't want to do is just stare at your code and say, well, maybe this is wrong. Let me just try changing this. You want to try to go about it systematically in some way. Try to understand what's happening so you can fix it. And there are tools built in, what's called the debugger, to help you do that. So I think the best thing to do at this point is just go to the exercise, because today's exercise is we're going to give you a script that has a bunch of errors in it, a bunch of bugs. You have to find and fix all the bugs. And just for reference, here it is also in the ebook, a table of common error messages. Okay, to kind of, as you get more experience, you start to understand, okay, when I see this error message, it usually means this. But in the meantime, this table might be helpful for you. All right, let's go to the grader then. Only one problem, but it's a long one. Okay, so we're giving you this script, and there's even a local function down here at the bottom, and has a bunch of bugs you have to find and fix them. So a bug can be several things. It can be a syntax error. It's just not even valid MATLAB. It can be a runtime error. Right? So it's valid syntax, but when you run it, something goes wrong. You know, something wasn't defined properly, an indexing error with an array, something like that. Or it may run perfectly fine, but it gives you the wrong answer. Right? That's a bug too. So we have all three of those types of bugs here. You have to find and fix them all. Now, I encourage you not to try to debug it in Grader, at least not at the beginning, especially because at least one of the bugs is an infinite loop. And you've probably seen what happens if you have an infinite loop in Grader. It's really a headache. So copy this. So Control A will select everything. Control C to copy. And then go to MATLAB and put it into a script. Control V to paste. All right, so get it running, get out just all the fatal errors here. Once it runs through without errors, paste it back into Grader, submit the test, and you'll see some of the tests will still fail because it's giving you wrong answers in some cases. And then you fix those problems. All right, so let's run it and see what happens. All right, so there's the first error. And the first thing you should do is look at what line the error occurs on. And you can even just click on this. If you click on that, it'll take you right to that line. Won't it? Come on, there we go. All right. All right, so it's taking me to the line where the problem is. And then read the error message. Invalid expression, check for missing multiplication operator, missing or unbalanced limiters, or other syntax error. All right, so one of these things is exactly the problem that we're looking at. Missing multiplication operator. And that's such a common error that it kind of anticipates that could be the problem. And that's what happened. Now, another thing, notice it underlines this in red. That's usually an indication that that's where the problem is. Maybe it's a syntax error. So you put the cursor on that and it says parse error, usage might be invalid MATLAB syntax. A parse error just means it was trying to read through your code to understand what it's doing, and it got to something it didn't understand. Right, so I think it's fairly obvious in this case what the problem is. We didn't put the multiplication errors in, multiplication operators in. All right, so that's the first one. Then you run it again. Right, now we hit another one. Line 9. And notice this error actually was earlier in the code than the previous one that we hit. But the previous one was a syntax error. It'll always find those first because it checks the syntax before it tries to run it. All right, so now we got rid of the syntax error. We run it, and it hits some kind of runtime error. And something wrong with the sequence of our code created an invalid condition. All right, so what is it saying? Unrecognized function or variable total on line 9. Okay, so you look at that, and you see, wait, I've got total on the right-hand side here. And if it's on the right-hand side, that means it has to have already been defined. But it wasn't. And so that's the problem. It's an initialization error. We're trying to add up all the numbers from 1 to 1,000, doing it the dumb way with a loop. But we never initialize the total. So we have to initialize that. All right, so now when it gets to this line the first time, total has been defined. So that'll correct that error. All right, let's run it again. Okay, it ran, it didn't give me any errors, but something's not right here. The prompt isn't coming back. So I've got an infinite loop. And remember, when you hit an infinite loop, the way you stop it, Control C. Okay. And helpfully, it even tells you where it was when you interrupted it. It was on line 16. So we can go there and see what that looks like. All right, so we have a while loop. And anytime you have a while loop, you're in danger of having an infinite loop. Okay, so now I'm going to show you the debugging capabilities. And so I know there's something wrong in this vicinity, and I want to see what's happening. So what I'm going to do, put a breakpoint here on line 13. All right, so how you do that is you click on the hash mark next to that line. And so in the future, as the TAs and I are helping you debug your programs, we may often say, put a breakpoint on line 13. Well, that's what we mean. Go there, click on that hash mark, and that red dot will come up. So now when I run the program, it'll stop on that line. Okay, so you see now there's a green cursor, a green arrow, that says it has run up to that line and paused. And now I can single step through the program. See up here where it says step. Click, and it goes one line. Every time I click, it advances one line. Okay, so you can see how it's executing this loop. Right, just as you would expect, because that's what a loop does. Now I can look at the values of these variables. And you can look in the workspace over here, or you can just take the cursor, put it on the variable. So I've run through several iterations of this loop, but the total is still 0. So that doesn't seem right. What's K? Well, K is still 0. That doesn't seem right. So now it should be obvious what's happening. We never incremented K. Right? That's why we have an infinite loop. Now I'm going to let you fix that one. But to get out of this, so I can continue with the rest of the program, what I'm going to do, I can actually temporarily change the value of K. I can go to the command line and say K equals 1,000. And now when I single step, so next time it checks this, this will no longer be true, so it'll exit the loop. Okay. Now, the next time I run it, K is going to go back to being what it was before. That's just a temporary change. All right, so that's single stepping. Now, another thing you may want to do, you may just want to run up to the next breakpoint. Like I've got another loop here, and I don't want to single step through this whole loop. So I'm just going to set a breakpoint later on and type continue. Okay, so continue just means run up to the next breakpoint. Okay, so that's what it did. And now I can go back to single stepping if I want. Let me start over and put another breakpoint inside the loop. Okay, so now again, I stopped inside the loop. So now if I click continue, it's going to stop the same place every time because it's repeating the loop, and it's going to stop every time it hits that breakpoint. And if I've run through a few iterations of this loop, and maybe I've decided, oh, this isn't really where the problem is. Now I can take out the breakpoint, put a continue, so put a breakpoint somewhere else and click continue. Oh, that's right, I forgot. It's infinite loop. So it's not going to continuing is not going to do me any good because I have a different loop. So let me get rid of that. Once again, I'm just going to temporarily change K so I can get out of this loop. Okay. right, so you can set a breakpoint, single step, continue, and if you decided you don't want to stop at that breakpoint anymore, you can just remove the breakpoint. Let's see. Now, there's another thing I want to show you, but it's a problem because of a syntax error, it won't do what I want it to do. So what I'm going to do here, I'm just going to put something GPA. So that's a function. There's this local function here. I just want to show you how you can step into a function. Let me put a few of these here. And since we haven't fixed the problems with any of these earlier sections, I'm just going to comment them all out. So here, this is also a useful debugging technique. If you've got a section of code that's giving you problems and you don't want to deal with that right now, you can just take it out by commenting it. So you select and then you type Control-R, or you can come up and click on comment here. Rather, Control-R will comment out that whole block of code. Okay. And then to get rid of that, you select it again and type Control-T, or one of these buttons up here is uncomment. All right, so I'm going to set a breakpoint here. Now notice that breakpoint is gray. That's because I just made changes to the file and I didn't save it yet. So if I save it, now it goes back to red. When I run it, it stops in that breakpoint. Now if I just click step, and because of bugs, I can't go anywhere here, but if I just click step, it would have just gone to the next line. Let me very quickly comment out all this stuff. Okay, so I don't get into trouble with the bugs that haven't been fixed yet. All right. Okay, so step just steps through one line in the main program. But if I do a step in, then it steps into the function. Actually, let me put something here so it has something to stop on. Okay, so if I just do step, it just goes to the next line. But if I do step in, that takes me into the function, and now it'll single step through the function. Okay, so it depends on what you want to do. If you think the problem is inside the function, you may want to do step in so you can trace through the function. But if you're pretty sure the problem is in the main program, then you might just do step. All right, last thing. So now I'm going to uncomment this, Control-T. Last thing I want to show you is conditional breakpoints, where you don't want to stop every time. You only want to stop under a certain condition, like when a variable takes on a certain value. So let's say with this, there's some problem with this first loop, but I think the problem is happening at the end. Something isn't working quite right at the end of this sequence. And I don't have to step 1,000 times to get there. So I can right click on this, set modify condition, and say only stop when this condition is true. So let's say when number equals 999. I run it. So it already ran through the first 998 iterations. Now number is 999. That's what the total is so far. And now I can single step. And now it'll reach 1,000 and it'll step out. Okay. All right, so as you're debugging this exercise, maybe take some time to experiment with these techniques. And there's a video in the a link to in the presentation from MIT OpenCourseWare that goes through all the same stuff I did. This is old, but I think it's all still valid. All right. Any questions about any of that? All right, so go to the exercise. And again, I urge you to copy it into the desktop first. Get it so that it runs through to completion. Then copy. And paste it back here. And then submit it and see which tests fail and then try to fix those. All right, so we will stand by to answer questions.
My MATLAB's not letting me add breakpoints.
Well, we'll have to look at that in a breakout room, I think.
Okay.